I have no idea. Or she's excused. So.
She has an ear infection, I heard.
Anyway, so what we're going to talk about today is how to solve these equations that have exponents in them. And the idea behind it isn't that difficult, but you do want to be paying attention because it's not supernatural. Like, it's not going to become something that you would think of on your own. Okay, and what I'm going to do up here at the top is give you an example that's a little bit easier to kind of explain how this works. So if we had something like 2 to the power of x equals 32. This is basically saying we want to figure out what power of 2 equals 32. The issue is you may not know what power of 2 equals 32 yet. So what you're going to want to do today is try different powers of 2 until you find the one that works. So for instance, I could try 2 to the power of 3. That's 8. I need to keep going higher, so I'm going to try 2 to the power of 4. I'm almost there. It's 2 to the power of 5. So in this case, x would be 5.
Ellie's on Snapchat.
What?
It's Ellie. You're not on speaker, stupid.
So we're looking basically to fill in the exponent. The exponent is always going to be the variable. Sometimes it'll look something like that, and sometimes it'll look something like this. 3 to the power of x plus 2 equals 3 to the power of 5. Both sides have to have the same exponent because they have the same base, 3. So basically we're asking ourselves what number plus 2 equals 5. That would be 3. Yeah, you can go one right there. On the shelf, sorry. That's where they normally go. I've just been going to the library each day, so I have them in the spot.
Yeah, you've been born.
And actually, I'll pause there. If you want a calculator, come grab one. There are a few main rules we are going to follow. The first one is that these are going to be equations where the exponent is a variable. Here is the thing as we solve these. There is no way to get something out of the exponent. We don't know how to do that, and we won't learn how to do that. You won't know how to do that until you talk about logarithms in Algebra 2. But for right now, we're going to sort of work around it. For instance, up here, since these are the same number, I know that the exponents have to be the same. So I just kind of figure out what value makes these two equal. I'm not really getting rid of the exponent. I'm figuring out how to work around it. Okay? And what we're going to do is we're going to make sure that we have two things that have the same base. So I'm going to put two A's on there. One has a power of x, one has a power of y. If these two things are equal, then x and y have to be the same thing. That's the whole idea behind today's lesson. The hard part is making sure that they have the same letter down here, or the same number down here. We actually won't have any letters down there. Those will only be in the exponents. I know that sometimes when we do it just in letters like that, that doesn't make much sense to people. So if that part doesn't make sense to you, hang on tight till we get to the first example down here. The first thing you need to do is make every exponent have the same base. This is the hardest part of today. The rest of it will be pretty easy. It's things you've already learned before. That's the new part. By same base, that means they either both need to be a power on 2, or they both need to be a power on 3. Or they both need to be a power on 4. They need to have the same number. Because once you do that, you just set the exponents equal. Which means that the bases go away. And the base is the bigger small number, or bigger number at the bottom. Exponents are the tiny ones up top. And then you might have to solve it like a regular equation. That third step, I know you guys can already do. We've done that part a lot before. You guys did awesome on it, especially at the end of semester 1. Here's what all this means. When you first look at a problem, decide, are these two bases the same number? Yes, they're both 3. So that's step 1, done. Step 2 says set the exponents equal. If these two things are actually equal, like the problem says, then this has to equal 5. And you could think about it as what number plus 1 equals 5, and that's fine for this problem, and it'll get you there if it's a problem like this. But sometimes it'll get a little bit more complicated, so I need you to also understand that this is just an equation that you can solve as well by subtracting 1 to the other side. And you get 4. You can always go double check this because if you plug in 4 for x, that's 4 plus 1. And 3 to the 5th power equals 3 to the 5th power. The whole idea here is that if you have the same number, these two have to be the same. Otherwise, 3 to the 5th power is never going to equal 3 to the 2nd power. Those aren't the same number because they have different powers. Okay? And on this top row, you'll notice that they all have the same number. 6 and 6, 10 and 10. But then it starts changing on the second row. So it does get a little bit harder than this. On the second question, we want to set these exponents equal, but what exponent does this 6 have? Well, it doesn't have 1 yet. What exponent can we automatically give anything that doesn't have 1? 1. So we're going to say 1 equals 2x minus 3. Or if you're like me and you don't like that it's set up that way, you can say 2x minus 3 equals 1 if you want. I'm just flipping it to the other side. This is now a 2-step equation. We can solve these. The whole idea is you take these out so that it's something you're more familiar with. Add 3 to the other side. 2x equals 4. Divide by 2. 4 divided by 2 is 2. Okay, and then I'm going to do one more that already has the same numbers. You're just setting the exponents equal and then solving. On this one, it's 3x equals 2x plus 3. And then you're going to solve this equation. The main thing you have to do to start is get over the fact that they look scary. They look way harder than they actually are. And then I'm going to minus this 2x, because if you want to move it on to a different side, you have to do the opposite sign. Since it was 2, I need to do negative 2 to cancel it out and move it to the other side. 3 minus 2 is 1x. You don't have to write that 1. Like that. Okay. Here is the part where you need to be paying attention because it's going to be a little more difficult if, like on this fourth one, you don't have the same number. So there's a 5 over here, and there is not a 5 on this side. So what we need to do is change that. We're going to leave this side the same, and we're going to rewrite 125 as 5 to some power. We just have to figure out what power that is. And you're going to have to try it out in your calculator until you find it. So I'm going to try 5 squared. That's only 25. So now I'm going to try 5 cubed. That is 125. You're not always going to know the number automatically. You're going to have to use your calculator to sort of guess and check. But don't just guess and check in a wild and unplanned order. Go like 2, 3, 4, 5. I probably won't give you any exponents that are higher than 5. And now they both have 5s down there, so it's just x equals 3. And it's not canceling an exponent out, it's more just like we're ignoring the bases for a second. And that's your answer. over here, we have to find a number that we can rewrite both of these as. So the smaller one is already 2. We're going to try to see if I can rewrite 4 as 2 to some power, which happens to be 2 squared, is 4. There it goes. So I'm going to change the 4 to 2 squared. And then the x is still going to be there. You can't just ignore that x that was already there. And I'll tell you what to do with that parentheses in just a second. Okay, this goes back to what we talked about in 5.2. What's going to happen with these two exponents if one is outside the parentheses and one is inside the parentheses? Yeah, distribute or multiply. I'm going to put a little multiplication out there. That makes 2x. 2 times x or 2x. And the other side has an exponent of x minus 3. Now that we have the same number down here, we don't actually care about it. You just have to make sure it's the same number before you can do the next step. And then I can subtract this x. You can make it minus 1x if that helps. And 2 minus 1 is 1. And that's your answer. As long as you get just x by itself, you're good to go. And then there's this third one. Out of these 3 in the second row, this one's probably the trickiest. Because if I do powers of 9, 9 squared is 81. 9 is 9, 9 squared is 81. There's no way to stop in the middle at 27. So if this number can't be rewritten to a power to get you this number, you have to try something else. Does anybody know what other number 9 could be written as a power of? Like, is it something squared? Yeah, 3. So we're going to rewrite this as 3 squared. And then I need to figure out what power of 3 is 27. Since I already know that 3 squared is 9, 3 cubed comes next, and that's actually my answer. Since 9 didn't work, we had to go down to 3. Remember that has to be a number times itself if you're squaring it. And then when I go to distribute this, it has to go to both of them. So instead of just 2x, it's got to be 2x and 4. Right? Or you can just kind of like cancel out your bases as long as they're the same number. And then we're going to subtract that 4 to the other side. And this one's going to be a decimal. It's okay. 2x equals -1. And then I'm going to divide by 2, which is going to make it -1/2. It's kind of like solving a regular equation. You just have to get the right setup before you do. Okay, and then we're going to make a note at the bottom about the bottom row. What do you notice is different about all of the ones on the bottom row? They have fractions. And I know fractions freak us out like crazy. The rule I want you to remember is that negative exponents make fractions. So anytime you see a fraction in your problem, one of your exponents was negative. So for example, on the first one, 6 squared is 36. But since that 36 is on the bottom, this is actually 6 to the power of -2. That's the only difference. You can almost pretend like it's on top for a second, but when you go to write your exponent, make it negative. This one already has a 6 as a base. And then all you have to do is set the exponents equal. So fraction problems are almost the same. It just adds this little negative right here. And then you would have 3x equals -2. Don't worry about the fact that this is going to be a fraction answer. It actually saves you a step because it's just going to be -2/3. So you don't have to actually divide it if it's not going to work out nicely. Right? There are going to be some fraction answers. And then in the middle here, we have a 2 inside the parentheses. So it's going to be a base of 2, but since it's on the bottom, it has a negative exponent. Since it didn't change the number is still 2, that would be a -1. Because all that 2 did was flip, it didn't change to 4 or 8 or anything like that. And then we already said this earlier, 2 to what power is 4? 2. So then we have these two being multiplied. And somebody earlier asked me, can I just leave that as my answer? You can't just leave that as your answer because you want x, not -1x. All you have to do is divide by -1. Or, for those of you who can think this way, you're just switching the negative to the other side, is really all you're doing, if you don't want to write all of that work out. Okay. And then same thing on this third one. We've got a base of 4 on the left. We want to know what power of 4 makes 64, so that we can figure out what power of 4 makes 1/64. Oops, I checked the wrong thing. And it's 4 to the third. So 4 squared is 16, 4 to the third is 64, which means this is simply -3, because it's a fraction. Again, fractions mean your exponent was negative. And then you just take the exponents, which means x plus 1 equals -3. And how do I get x by itself? It's my last step. Mm-hmm.